these machines to run the file fuzzer, and these machines were often used for doing the rest of their testing. So they would set up the fuzzer on a Friday, hopefully enjoy their weekend, come back in on a Monday, look at the logs, but a lot of times at that time they had a private release or something from the developer saying, hey, I need you to go and test this, so they would have to stop their fuzzing, and that's obviously not ideal. So this became a bottleneck. The machines themselves became a bottleneck for fuzzing. And then there was no way to easily leverage unused resources. So if the Word team finished their fuzz runs, the Excel team may not know that, hey, maybe I should go talk to this Word guy and I can use this machine when it's not being used and stuff like that. So now David will talk about some of the goals of the distributed fuzzing framework.
Thanks, Tom. I'm excited to be here to show this off today. This is one of the first big demos we've done outside of Office with DFF. So before I get started, I just want to gauge the audience a little bit. So if you could raise your hand if you've done any fuzzing or anyone on your team has done fuzzing. Could you raise your hand? All right, and keep your hand up if you're fuzzing across like multiple machines. Are you using just one machine, or are you using machines across your team? If you're using them across your team, put your hand up. All right, and then how about cataloging failures? Can anybody out there say they have every single failure they've ever found and can run them like on a minute's notice? Two. I also didn't see your hand up. Do we need to talk afterwards? Because I thought we had this all set up. All right, anyway, I don't come from Tom's team. I come from a product team, as he noted before. So this was built out of necessity. We actually used this on the last version of Access to ship it. So it was a big benefit there. My team came to me and said, hey, we need to meet the SDL. And you need to do it without spending any money. And I said, well, okay, I can meet the SDL, and I'll do my best to exceed the SDL. And I'm going to find a way to do it without spending any money, except you have to keep paying me. So that was the only caveat there. We've actually done this without spending any money. In fact, all the servers we use are recycled hardware. They're old hardware, so we don't have top-of-the-line servers because we don't need them. The framework's very light, and so we've actually been able to completely reuse. So today I'm going to go through DFF for you, and I'm going to go through it based on these goals that we have outlined here. So I'm kind of going to break down the system based on these goals and show you what it looks like. So let me start with these first three. Teams don't need to manage hardware. You can use any machine with Office installed on it for fuzzing. Now, of course, this is in the context of Office, but if you were not an Office team, you wouldn't need Office. And machines join in fuzzing with multiple products and runs. So how do we do this? This is the architecture of our system. So teams can take their resources and dedicate them in. I can tell my team, hey, I need your help with fuzzing, run DFF, and contribute your machines into our system. Those machines contribute into an infrastructure that's managed by TWC and the DFF admins. So the teams don't have to manage any of this hardware. They don't have to manage the backend database, the file stores, anything. That's all transparent to them. And these big, huge existing labs that we have, these resources can be shared across multiple teams. You know, one team isn't going to go try and figure out how they're going to leverage them. Everybody gets to use them, and they all plug into DFF transparently. And what this means is that teams in Office can use DFF without supplying any hardware resources. They can just immediately start using it. They don't even have to use their own team's machines, and they don't have to buy any hardware. So this is the actual DFF client that runs on the machines. And so the first thing I'll note here is that what we said before, we can contribute this to any team. So here we're contributing to TWC's work, but this could say all or Excel or PowerPoint or whatever team it would be. We made this very simple. So when I pass this out to my team can immediately begin using this and doesn't really have to figure out much. I spent the extra time to color code the buttons. I thought that would be easy. Most people understand a stoplight. I just tell them press the green button when you want to start and press the red button when you want to stop. Or you could press the yellow one if you're like, well, I'm going to go get coffee first, and you can stop on at some point. And then we added additional settings to the client to make it easier for team members to use on their machines. So you can think about this like if you stay up late, which I know a lot of security people do, and you have the TV on, you get all those infomercials, so you know the Showtime rotisserie grill. Same thing here. Set it and forget it. That's what we like to say. Because we have start on Windows lock, stop on unlock. So again, the tester can put it on their machine, set those settings, and they don't have to worry about it again. It'll just run on its own and pick up the work that it needs to do. So this is a view from the web of the system. And as we can see, this is just a small snapshot looking down. And some of the machines are dedicated to specific products like Access or Excel we can see here. And then some of those machines are dedicated to everything, like those machines that start with BB, which is one of our big labs in Office. We can also see the settings right from here. I can see the status of my machines. Maybe one has gotten hung up. I can kind of see what's going on from a high level here. And I can even move machines between teams and runs. So if I see as an administrator of the system that Access isn't really doing anything, and there's some machines that I own there, I can move those over to do work for Excel or for someone else. I can also control specifically the work. So literally I can kind of take remote control from the web of what those machines are going to do. Oh, and I will say, it says 556 million files we've done so far. We're a lot closer to 600 million now. So just churning through the files. And this is just one server. So that's how we met the first three goals. Let me go on to the next ones. So we wanted to be able to run any fuzzer, anything that generates files. We wanted a simple way to define a run. We didn't want people to have to know a lot about fuzzing necessarily to go in and get started. We wanted to just make it a very easy to use interface. And we also wanted to automate regression of previously found crashes. So that's where I kind of asked you, could you go through and rerun all your files? Well, in DFF, we wanted you to be able to answer yes to that. So teams have large sets of fuzzers in different combinations. Tom said we have 300 formats. My team specifically has about 22 formats that we parse. And so we have a lot of different configurations of our fuzzer to target specific files and specific types of files and parts of the file. And so we have hundreds of configurations in the system across many different types of fuzzers. And they're all, here's an example of some that are listed in this dropdown. And setting up a fuzzer is easy. You're just going to fill out a form. And we can do diffs of fuzzers. So this is great from a supportability standpoint. If for some reason there's a bug in one of the fuzzers that needs to get fixed, we can just make a fix to the fuzzer, and it'll populate back across all the fuzzers that inherit from that. So we're also conscious in space there too, where we don't want to have some huge fuzzers that we've just duplicated over and over again. We can use any fuzzer or any tool that generates files. So this is a simple example where we've just defined the arguments for for an exe, and away we go. It's that simple. DFF has some specific requirements of what your tool has to do just around generating files to a specific location and accepting files from a specific location, but that's really about it. So this goes further than just mutational-based fuzzers. If I have a generation-based fuzzer, I can easily plug that in here. We've had teams ask, hey, can I maybe not do fuzzing? I just want to generate a bunch of files and see if they work in my product. Well, you could really, in essence, you can do that here. And it's great for proof of concept fuzzers. I'm just developing a little tool. I want to see how it's going to work. We just plug it right in. You don't have to worry about any big framework that you need to sync up with. And we go further than just mutation-based random fuzzing. You can distribute ActiveX fuzzing we have here. So we do sequential fuzzing too in a distributed environment, and that's not pre-generated files. We do support pre-generated files, but in this case we actually distribute the generation of the files sequentially. Now I said we wanted to make the run definition very easy. This is an example of where we're going to define our runs. And we actually only have about 8 settings that need to be defined to create a run. We have different types of runs you can create. So you can create runs that are just generated. You just define it once and it runs one time and you get your results back and you're happy, or maybe not so happy. You can define runs that regenerate over and over again based on heuristics. So I define it once, it keeps generating over and over. Maybe when I investigate it, it regenerates itself. Maybe when a new build comes out, it regenerates itself. We have all those settings plugged into DFF so it can do that all automatically for you. Again, another one of those kind of set it and forget it features. We also, again, coming into the regression aspect of the system, you can easily define a retest of all previous failures based on maybe a call stack, based on a bug ID, based on just a run. And we'll take those failures both from your own product and any other product that defined that they had seen that bug as well, and we'll run them. And we'll run them in a matching configuration. So we're not going to use some random tool to actually test them out where it might or might not fail the second time around. We're going to use the same tool that we used before. We're going to try to use it on the exact same configuration that we had before so you get the best results possible. Because this came from a product team, I was specifically aware of how we worked on product teams and how we actually wanted to define our work. A lot of times we might have a bug that comes up that's kind of blocking our fuzzing, and we didn't want to waste time with machines, continually testing on that. So we have simple things like